Imagine pointing the most powerful laser ever built directly at a planet, firing it with all the energy humanity, or even an alien civilization, can harness. Could a single beam of light truly destroy a world? Lasers are among the most focused and high-energy tools we've ever created. But when it comes to planets, we're talking about masses trillions of times bigger than any machine. So let's explore. Could a laser really blow up a planet like in sci-fi movies? To destroy a planet, you don't just need to heat the surface. You need to overcome its gravitational binding energy. For Earth, that's around 2.24 times 10 to the 32nd joules. That's roughly a trillion times more energy than humanity uses in an entire year. Even the most powerful lasers today, like the National Ignition Facility or hypothetical gigawatt-scale space lasers, are nowhere near that strength. To crack a planet open, you'd need something many orders of magnitude more powerful, more like a Dyson sphere gathering energy from a star for centuries. Assuming you somehow built a laser that strong, the first thing you'd notice wouldn't be explosions. It would be melting. The beam would start vaporizing the crust, turning rock into plasma. But this would take time. The molten material would radiate energy away quickly, forming a layer of superheated vapor. Some of this would reflect or scatter the laser, making things even less efficient. You'd basically be slowly drilling a glowing hole into the planet. If your laser kept going, eventually you'd reach the mantle, and then the core. Heating the core enough could potentially cause internal pressure to build, like overcooking a pressure cooker. Still, this wouldn't shatter the planet in an instant. Instead, the planet might crack, erupt with massive volcanoes, or even partially fragment. But complete disintegration? That's still not guaranteed. To fully obliterate a planet, tear every rock and atom apart, you'd have to deliver that huge gravitational unbinding energy almost all at once. That's the key difference between melting and destruction. The closest real event to this would be a massive asteroid impact or a nuclear chain reaction the size of a moon. Even those wouldn't blow the planet up entirely, just deform or scar it. To actually explode a planet, you'd need technology so advanced it borders on the magical. Let's say somehow a laser did destroy a planet. What then? Billions of chunks would fly into space. If it was Earth, that debris would stay in orbit for years, crashing into satellites or forming dangerous asteroid belts. Nearby planets would be bombarded with planetary shrapnel. The solar system's balance would shift. Moons would go rogue. It could even trigger chain reactions that destabilize other orbits. Apart from the fact that it's nearly impossible, the ethics of destroying a planet are horrifying. Even testing such a laser could boil oceans or sterilize life. And if we tried it near Earth or Mars, it might backfire in ways we couldn't predict. Plus, in sci-fi, blowing up planets always leads to galactic war. Maybe there's a reason no one's tried it yet. So, can a laser destroy a planet? Technically, maybe, if you had godlike energy and centuries to focus it. But practically, number. It's one of those sci-fi ideas that's much cooler on screen than in real physics. Destroying a planet isn't just hard. It's probably one of the hardest things the universe could ask you to do.